or maximum compression, in what direction the blocks will be having velocity? This is the first question what you have to ask. They will be having velocity in the direction of velocity of center of mass or in the direction of initial momentum, either one. So let me prefer the velocity of center of mass. So what is the state of the block? They're given velocity. Center of mass will be here, no? What is the velocity of center of mass? This let me keep as it is, reference diagram. No, what is the velocity of center of mass? BC. First we'll calculate velocity of center of mass. This should be equal to 3 mv minus 2 mv by 3m plus 2m. V by 5. Speed of center of mass. What direction? Towards right. Positive means towards right it is. No, finally, so what happened at maximum elongation? How the velocity of the block should be? In the direction of velocity of center of mass only. So at maximum elongation, first what actually happens? I'll give sequence of diagrams. So this is the block A in what direction? First it will try to move towards left, and block B will moving towards right. So this you call VB1, VA1. There's elongation of spring KX1. This is not maximum elongation. And somewhere it will come to rest because the spring force is acting opposite to velocity of block P. And it will have some elongation KX2. Shall we call this as maximum elongation? No. Elongation. This is also elongation. So can you call this as maximum elongation? No. Sir, how come that is? This must be the maximum elongation. Sure. No, this is not maximum elongation. Because what is the basic idea? At maximum elongation, how the velocity of block should be? Should be directed in the direction of velocity of center of mass. How center of mass will be moving in all the cases. Now also center of mass will be moving. Now also center of mass will be moving. I think this cannot be maximum elongation. Is it okay now? I'm giving some very simplified approach. Please do accept this. Nothing else is there. Now at maximum elongation. So now what will happen? The block has come to instantaneous rest. So now what will happen? Again, it will start moving towards right, and this will continue to move. VB3, you call this is VA3. Now this is KX3. This is also elongation. After this, I'm coming to the now the maximum elongation. I have to show more, no? So I come to the diagram. So this is the maximum elongation. Center of mass will be moving like this. They'll be moving with a common velocity B, and this is Z. Now what should be V? Definitely it should be equal to V by 5, no? Or you apply conservation of Lee and check it. It will be V by 5 only. Sir, are you sure? Okay, let me apply. Initial momentum equal to final. Initial momentum 3 mv minus 2 mv. Final momentum. Okay, that's I'll write it some V naught because let me take it here. So this should be equal to how much? 3 mv naught, 2 mv naught. So please do look at the, I think diagrams are visible. Check it now. So how much we are getting V naught? V naught is V by 5, which is nothing but equal to velocity of center of mass. Okay, now whatever happens here, at maximum elongation or compression, the blocks must have velocity in the direction of velocity of center of mass. And they must be common velocity. And see, like both will have same velocity. This is the maximum elongation. I want that maximum elongation. How to calculate? Again, applying conservation of mechanical energy. I'll write the equations here. Initial, how much we are given? 3 mv square, no? So 3m v square by 2, 2m, velocities are given v. This should be equal to how much? 3m v naught square by 2. Same problem. Can you bring in ground frame? In C frame, what actually happens initially? In the C frame, what actually happens? I don't. I better let me give nearby it. It'll be easy for you. Now the same speed of center of mass. Okay. Now in C frame, let's discuss the problem. What actually happens? How they'll be moving? What is this in the C frame? For this, what we needed even the velocity of the blocks. No, how to calculate that? What is the formula? VAC is equal to VA minus VC. I'll write it here. No, VA is how much? Minus V. What is velocity of center of mass? V by 5. So calculate 4V by 5. So in what is the velocity of this will be VAC like this. What about VBC? VBC equal to VB minus VC. This is equal V minus minus 6V by 5. So look at the 6V by 5 it should be. This should be how much? 4V by 5. This is what initially what will happen with respect to center of mass, they'll move away. Okay, fine. Agree this? This is in C frame. Huh? This is what in ground frame. Please do analyze this. This is very important. You should have a parallel diagram. Ground frame, C frame. Don't go for other diagrams, not needed for us, not very important. Now come for it maximum elongation. Again, now in the ground frame, in the C frame, how it will be? In the C frame, anybody, what should be the blocks? They must be at rest, no? In the C frame, and the elongation is maximum. Spring force is what I have to show like this. So here also, what will happen to the blocks? They are executing SHM. They are oscillating about what? They are oscillating about the center of mass. They are oscillating about the center of mass here. So what are the questions now? Maximum elongation, maximum compression is asking. Okay, what about maximum compression also? Same answer. So shall I directly conclude here? XM is both maximum elongation as well as compression. Will I agree all of you? Yes, it should be. Again, in C frame, at maximum elongation, what will happen to blocks? Maximum elongation compression, which will be at rest with respect to C frame. Okay, this is about maximum elongation or compression. But what was the other question? The other questions were asked about the V max, no? Where the speed of the particle will be maximum, where the speed of particle will be minimum. How to decide this part? What actually happens to the motion of the block B? What will happen to motion of the block B? No? After maximum elongation, what will happen to speed of the block? I think we have to do analysis from that particular thing. Again, take help of initially what is V relative. Again, this is going to help us. What is V relative? Anybody? It should be 2V, no? And what is V relative at maximum elongation? Should be 0. Take help of this. Both will have common velocity. Now, how to calculate that maximum minimum speeds? I'm bringing the question. Maximum speed of the block, minimum speed of the maximum speed of the block A, minimum speed of block A. Where the speed of the block will be maximum. That's what the question is being asked. Whose help we have to take? Center of mass only. There's nothing, there's no other go for us. When the in center of mass frame, what is the motion of the block be? First, it will move away, reaches right extreme, comes to instantaneous rest, then again moves towards left. No, so at one instant in the ground frame, will the block B will be at rest. Yes, it can happen. So no, so I'll after this, what you after maximum elongation, again elongation. Let's see what conditions will arise. What is the velocity of block A, VA? We don't know this. We have to calculate. In C frame, how it will be at natural length? The red color box is what? The C frame. Again, it will attain natural length. Why it should be? Because it is a sequence, no? Spring at natural length. Now, what should be the V relative? V relative should be equal to 2V, no? V relative should be equal to V. We don't know both VA and VB. In the ground, there's a ground frame. And there's the C frame. Okay, now already we have some basic idea, no? In the C frame, how they should be moving. Again, when the spring attains natural length, because after elongation, maximum elongation, then natural length. So spring at natural, next sequence, natural length. Here I'm bringing. So can we apply conservation of according to the center of mass, come for this? What should be the velocity here? Take help of this. VAC, how it was? 6V by 5 towards left. No, again spring attains natural length. It should be VAC should be towards right. If you can think this much, problem is over. If you are unable to think this, then nobody can help you. I'm telling you this one, nobody can help you. Sir, why you are putting VAC? As I told you in C frame, what pen? It will just describe oscillating motion. No? First, natural length, VAC towards left. Again, it'll come to at maximum elongation. What will happen? There'll be instantaneous rest with respect to C frame. So again, when they come to natural length, VAC should be towards left. So can we calculate now VA here, the velocity of the block, looking at this diagram? Looking at this diagram, we'll calculate. So VAC equal to VA minus VC. Vector thing you have to take it. Towards right, I'll take it positive. So VAC already we know. How much it is? 6V by 5. Please look at this data. Magnitude, 6V by 5. VA, I don't know. And this should be equal to how much? V by 5. V is equal to how much it will be? 7V by 5. Similarly, let's calculate the VBC. VBC is how much? VBC, come for this. Magnitude how much? 4V by 5, no? Magnitude should be 4V by 5. What direction? Towards left. Velocity of center of mass? plus v by 5. The unknown thing, leave it. The unknown thing is what? VA, VB. So what is velocity of VB I'm getting? Minus 3v by 5. So when it attains natural length, again, so what is the state of the block B? Block B is having velocity towards left. We assumed it towards right. I think diagram correction is needed, no? The block B will be moving towards left. So block B moving towards left means
Sir, your voice is breaking, sir.
Their voice is breaking.
Now, can you hear me?
Yes, sir.
Can you hear me clearly?
Yes, sir.
Now can you hear me?
Yes, sir.
Can I continue?
Yes, sir.
Last 5 minutes. This I'll end up here because almost we have reached concept. Now come for this at maximum elongation. What is the velocity of the block B? Was towards right, no? From maximum elongation, it should reach to natural length. So by the time it reached natural length, what happened? The velocity of block B has become minus 3v by 5. So what happened? The block B, the velocity of the block B decreases. The velocity of block B decreases, becomes 0. Then it starts moving towards left. That's why we're having this minus 3v by 5. So somewhere in between, it should come to 0, no? Because at maximum elongation, it is how much? V by 5 towards right. I'll write it here later on in the video. You can check it. V0 by 5 towards right. At maximum, again, when it attains natural length, what is the state of the block? The same diagram I'll put once again here. So this will be actually the velocity. This is the natural length. So for velocity from what happened? From V0, from V by 5, from V by 5 to become minus 3V by 5. It should change direction. So what actually happens? It goes, decreases, becomes 0, then it starts increasing. So somewhere it has become 0 here, no? So shall I put one more diagram? What is that? Somewhere in between, the block A will have velocity, block B will be at rest between this maximum elongation and natural length. So what is the minimum velocity of B now? Not minus 3 by y, will be in fact 0. Sir, what about maximum velocity of the block B? Okay, is it okay, no? Why? Because the velocity of the block B from, like here what happened? It was how much in V by 5. Now finally what happened will become 0. Then it starts increasing. Then it becomes 3V by 5. Changes direction also. If an object to change direction, what happens? First velocity decreases, becomes 0. Then it starts increasing. So minimum velocity should be here only, no? Where it changes direction of motion. Getting the idea, no? So this is what, without free frame, I think nobody can solve this. Negative sign is what? Very important here. What is the maximum velocity of the block A? We want maximum speed, no? I'll finish off. I think I took extra 10 minutes. I'll last one more. How to get the minimum speed? We got it here. What about maximum speed? I think we have to check it further, no? Is it speed can be more than that? Is it possible? More than V possible? Maximum speed of the blocks, can it be more than V possible? I'm asking anybody can interpret. Minimum speed, I brought it. Similarly, we have to show the maximum speed condition. So what is the maximum speed of the block should be? What speed we have given, that is only maximum speed, no? Because in overall sequence, it can never attain the speed more than V. Will I agree?
Yes, sir. V.
Yes, sir.
Simplest way of maximum speed of the block B should be equal to V only.
Yes.
So shall I put that? I'll concluding problem. Maximum speed should be equal to okay, now one important conclusion I'm telling. So when the speed of the block will be minimum, when it is having velocity opposite to velocity of center of mass, it will be minimum. Will I agree? Look at this VBC. How VBC is opposite to velocity of center of mass. Then the system, then the block will have minimum velocity. When it will have, when it will be maximum, the initial what we projected V. So when the velocity of the block is opposite to velocity of center of mass, definitely what happens, the speed will be minimum. That's what happened here. And it happened at natural length. And what is the maximum velocity of block B? It is equal to V, that one. Okay, similarly, I want the maximum velocity of this one, of A, that one. Anybody? Maximum velocity of A.
Maybe. 7 maybe.
Minimum velocity of A. First, let me check minimum velocity of A.
-4.
Somewhere 0, no? Here, minimum velocity. Here, look at this, instantaneous rest. Agree?
Yes, sir.
VA minimum will be 0. Do make observation. What about the maximum speed of the block A? Equal to V only. This is a maximum projected speed what we is having, no? So what is the maximum speed of this will be again? Or else what you check it anywhere it is greater than that one. So we have here VA 7V by 5. 7V by 5 greater than V or less than V?
Greater than this.
Greater than
Greater
V,
than
sir.
V, no? So we can't say V, no? So what we have to do, we have to check it further anywhere. Is it greater than V? We have to check it. I think we don't have any formula to tell anything directly here. We have to analyze here. So I have here, so I'll call this as maximum. No, sir, may not be. Check it and verify. If it is wrong, I'll correct it. Huh? Okay, got this one? So this is the, so shall we put it here? The velocity of the block when it is having in C frame, also like when velocity of the block, if it is having in the direction of motion of velocity, it will have maximum velocity. If it is having opposite to the velocity, then it will be minimum difference. So here look at the VB minus 3V by 5, opposite to velocity, so it's a minimum. When the velocity of the block is VA, can we calculate VA? VA 7V by 5. It is there in the opposite to velocity of center of mass, it will be maximum. And where it occurs at natural length. So there's a method of identifying that like a minimum maximum velocity. I think you should have both ground as well as C frame, no? And see that VA, VB, we can't find out until unless C frame. So, and always the things will get repeated. What is repeated? This sequence. It's in C frame when at natural length, what was the speed of the blocks? Then again from what point first they'll move away, no? Maximum elongation, they come to rest with respect to C frame. Again, when they come to natural length, their velocity should change direction because about C frame, they'll vibrate, they'll oscillate. In ground frame, they just move and will be oscillating. So in C frame, what things will be easier. So VAC, sir, how you are writing 6V by 5? This is very important. Any reason for that? Sir, why VBC you are writing 4V by 5? At natural length, what was the speed of the blocks? No, again, spring when any number of times it attains natural length, the block should have same speed in the with respect to C frame. Are you getting idea? In C frame, the sequence will get repeated. Initially, first natural length. What was the speed of the blocks at natural length in C frame? the same speed the block should have again when spring attains natural length. Are you getting this? This is a core idea. This is what I'm applying here. So without C frame, I think problem cannot be solved. So speed of the block set again when it attains natural length, I found